All right, you're in the home stretch, part 5 of 5 of the semester 1 final exam review. For number 55, it says draw some isomers, 2 isomers for each of these. So for the first one, C4H10O, I'm going to put my 4 carbons in a row and put an O on the end. And so everything works out. And then maybe for another one, I could do an O between 2 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That still works. Or I could do 4 carbons in a row and have the OH not on the end, but on the second carbon in. Or I could have done just 3 carbons in a row and put a carbon on the middle carbon and maybe the OH going from the top. So there's more too. So you just have to make sure that you don't accidentally draw it, in a new sort of a shape, because that's not really different. Like some people would draw this one a second time and do, oh, I'm going to put the OH over here. Well, this is still the same. It's 1, 2, 3, 4 carbons in a row with an oxygen on the end. Just because you drew it the opposite way doesn't mean it's a true isomer, which is the same formula and yet a different arrangement of the atoms. For the next one, you've got 2 fluorines to work with. So you've got 3 carbons. You could put both fluorines on the end carbon. You could spread them out and put a fluorine on each of the end carbons. I can think of lots of other ones too. You could put both fluorines on the middle carbon. These would all result in different shapes, even though they don't really look like a different shape because we're drawing letters and it's all two-dimensional. You have to remember that these atoms are different sizes, and so there's going to be different shapes because of those different sizes in different areas. The Octet Rule says that atoms want to have and need to have 8 valence electrons when they're bonding. There are exceptions, of course. There's something called an expanded octet, and some elements like sulfur can form them. But for our purposes, just know that hydrogen and helium are the exceptions that we see a lot of the time. They only need 2 valence electrons because they're small. For number 57, it says draw it and name the shapes. If you drew yours different from mine, then you might actually have some different shapes in there, and that's fine. So just be aware of that. Anytime you have 4 atoms attached to a central atom, it's always a tetrahedral. 1, 2, 3 tetrahedrals. And this oxygen, it's got 2 things attached, and these 2 lone pairs make it a bent shape. Same here in this one below it. Even though I drew this linear, because there are 2 lone pairs in 3 dimensions, these would be maybe coming out of the screen at you, and these 2 bonds here would be pushing into the screen. So they can get further away from each other than just 90 degrees. Here's another example of a tetrahedral and a new one. The phosphorus has a lone pair and 3 things attached. That's a pyramidal shape. We've got another bent and another tetrahedral in that 4th one there. More shapes practice. Here's a new one. 3 things attached and no lone pairs on the atom. That is a trigonal planar. And then these are more of the same. Electronegativity. Electronegativity is when you've got a bonded pair of atoms and one of them is greedier than the other one for electron cloud. So, example, if you check out your electronegativity chart, it gives you numbers, like oxygen is 3.44 and hydrogen is only 2.1. That's a difference of 1.34. If the range is between 0.5 to about 2.1, that means that that's a polar bond, which means that the oxygen is pulling more than its fair share of the electron cloud. Gotta go faster, my battery's running out. Okay, I should make this even bigger. Got distracted. Okay, so because of that, it's got a partial negative charge because it's got more of the electron cloud around itself. The hydrogens nucleus are more exposed. So those protons are really like, hey, the positive's winning here because their electron cloud's getting sucked away. Polar bonds and nonpolar bonds, the big difference is in nonpolar bonds, the difference between the two is less than 0.5, meaning like a carbon and a hydrogen. So a tetrahedral is nonpolar because carbon is 2.55 for its electronegativity value. Hydrogen's only 2.1. That's a difference of 0.45.